This is a video on using the limit definition to find area. The question states, use the limit definition to find the area of the region below the curve y equals x squared minus 4, above the x-axis, and between x equals 2 and x equals 3. So we start out by drawing a picture. So this curve right here, this blue curve, is y equals x squared minus 4. And we're going between 2 and 3, so here's our region. And I'm going to draw a general rectangle. I can think of this as the ith rectangle. And we have a base and we have a height, and I'm using right rectangles. And the height will be the y-coordinate of this point. So now let's proceed and find the base and the height. So the base, if we have n rectangles, we take 3 minus 2, because we're going from 2 to 3, and divide by the number of rectangles, n, and I get 1 over n, and that's the length of the base of the rectangle. Now let's look at the height. For the height will be the y-coordinate of this point. The x-coordinate, we're starting at 2, and then we're moving along I bases until we get to this point here. So what we can say is that the height is the function evaluated at 2 plus I over n, because I bases is I times 1 over n, or I over n, and f of something tells us get the y-coordinate. So now our f is x squared minus 4, so I can plug in 2 plus I over n into x in x squared minus 4. And I get 2 plus I over n squared minus 4. And I FOIL that out. And I got 4 plus 4i over n plus I squared over n squared minus 4. And now I'm ready to find the area of this rectangle. So the area is the base times the height. The base is 1 over n. And then I canceled the 4 minus 4 and got the height as 4i over n plus I squared over n squared. So we can multiply the n through. And then what we want to do is we want to get the full area. So now we use the limit definition and say that the full area is equal to the limit as the number of rectangles goes to infinity of the sum, we add up all the areas from I equals 1 to n, of 4i over n squared plus I squared over n cubed. So now let's manipulate this summation sign. We could write it as the sum of the first plus the sum of the second, and we could also pull out the constants. In the sigma, I is the variable, and 4 over n squared and 1 over n cubed are both constants. So I can rewrite this as the limit as n goes to infinity. I pulled out the 4 over n squared, and I'm left with the summation of I. I pulled out the 1 over n cubed, and I'm left with the summation of I squared. So now I use the formulas that say the summation of I is n times n plus 1 over 2, and the summation of I squared is n times n plus 1 times 2n plus 1 over 6. So I can simplify. This n here and one of the n's and n squareds cancel, and 4 over 2 is 2. This n here and 1 over the n's and n cubed cancel, and I get the limit as n approaches infinity of 2 times n plus 1 over n plus n plus 1 times 2n plus 1 over 6n squared. And I can multiply out here and FOIL this guy out, and I get 2n plus 2 over n and 2n squared plus 3n plus 1 over 6n squared. And now I can use a little rule about limits as n goes to infinity, and that's that I can ignore all the lower terms. So I can just look at the higher order terms. I can say 2n over n is equal to 2, and I can say that 2n squared over 6n squared is 2/6. So what I get is 2 over 1 plus 2 over 6, and that's 2 plus 1/3, which is 7/3. So my final answer is that the area of the region below y equals x squared minus 4, above the x-axis, and between 2 and 3 for x, is 7/3. And I'm done with the problem.